relationship. Now for correlation, we will go to linear regression. Okay, so correlation measures the linear relationship between two variables. Linear regression also does more or less the same thing, but there are many additional things that you can do with linear regression that you cannot do with correlation. So here is what we mean by what is the linear relationship and what is non-linear relationship, the strength of relationship, and so on. The first graph, just the correlation is -1. There is a strong negative relationship. So the line that passes through the dot points between x and y. So we're trying to measure the correlation between x and y, which are two variables, and it is negative sloping, right? It is downward sloping. Okay, so that's a perfect correlation, but it is a negative correlation. Go to the right, okay, and see the second graph. Again, the same. The relationship is negative, but the strength of relationship is somewhat less. If you see the line that passes through these points, it is not like the first one, where it is passing through all the data points. But here it is not the case. It is not passing through all the data points. Go to the third one. Here the regression, the linear correlation is 0. That means there is no correlation between x and y. If you change x, there is no change in y. Okay, so that's no correlation. Okay, go to the fourth one, the one here, the one I'm showing the cursor. So here we have, again, much like the first one, it is also the same strong correlation, and the correlation coefficient is 1, but it is upward sloping, so it's a positive relationship. X goes up, so does y. Go to the next. This is again positive correlation, but the strength is less. But the last one is again with no correlation. So this is typically the case of a linear relationship between two variables, and that's how that you can measure by correlation coefficient. Alright, so we'll try to understand now the linear relationship and curvilinear relationship, or in some sense, loosely we can say that non-linear relationship. The first one, you can see there's a straight line that can be drawn, or there is a very clear upward trend which can be depicted in a straight line. But if you go right, you see, if first there is a upward trend and there is a downward trend, it is not linear because it is changing the path, and we can not fit a linear line, rather we have to fit a curve. So that is non-linear or curvilinear. Similarly, third one, again it is linear, downward sloping but linear. Fourth one, non-linear, because it's not a straight line that actually can pass through these data points. It has to be a curve, and that's why it is curvilinear. So this is the difference between linear relationship and curvilinear relationship. Now remember, correlation is the linear relationship between two variables. Okay, Pearson coefficient in particular is the measure of linear relationship between two variables x and y, not the nonlinear or curvilinear relationship that we can see right side of this graph, the two graphs on the right sides, and not something that can be measured using correlation coefficient such as Pearson correlation coefficient. Now there could be strong relationship and weak relationship. Okay, if the data points are closer to each other, there seems to be a strong relationship, but if they are farther away, the relationship is somewhat weak. Okay, so you can see the first one, it is strong because the close one. If you go to the right, the first in the left, the two graphs on the left, they are the cases where we have strong relationship, but the ones on the right, you see there is seems to be a weak relationship. No relationship, cases where x doesn't, y doesn't increase with respect to x, or x doesn't increase with respect to y. Such is the case where there is no relationship. There is also cases where the data points lie parallel to either x-axis or parallel to either y-axis. If that's the case, even in those situations, we can say that the linear correlation is 0. So there is no linear correlation as such. We can calculate We can calculate correlations, of course, by using a formula. Of course, most of this modern softwares have their own function that can calculate the correlation for us, but we certainly can calculate by ourselves as well using the formula. And you can also have distribution of a correlation with standard error, and we'll talk more about it later in this lecture as to what the standard error is and how does it help us. Okay, so here is a bit of linear regression. Linear regression takes the more of some concepts, or rather some basic motivation from correlation. It also tries to find out relationship between two or more variables. Okay, while correlation is most of the times between two variables. At least the popular ones. Linear regression, on the other hand, can include more than two variables. Okay. Secondly, in linear regression, you have a dependent variable and you could have a set of independent variables, and we'll talk about what dependent and independent variables are. There's no such concept in correlation. In correlation, we cannot measure as to if x goes up by 5%, what is going to be the corresponding increase in y. That cannot be measured in correlation, but we can measure this in regression, in linear regression. So given a value of x, you can predict the value of y, which is another variable related to x, using linear regression, but you can't do that using correlation. That's another weakness of correlation, and that's why linear regression actually helps do a lot of things that correlation cannot do. So there is an example. So a regression line, basically, just to understand more of a layman language, a regression line is basically a straight line. And if you know your basic your school mathematics, a basic linear line can be represented as y equal to mx plus b, where b is your intercept and m is your slope coefficient. The slope of the line. Slope of the line is nothing but take the angle that it has with x-axis, take the tan of that angle, tangent of that angle, and that's nothing but your slope. And the intercept is just that where it cuts the y-axis, just measure the distance from the origin. That's your intercept. Okay, and you can represent that with y equal to mx plus b, and then given the value of x, and of course you need to know what m and b are, and we'll use that as an estimation process from the data, and given the value of x, you'll be able to predict the value of y. Okay, so it helps in predicting particular variable given another variable. Okay, in technical terms, what is a slope? A slope is just means that if there is a 1 unit change in x, what is the corresponding change in y? Okay, so which is like delta y divided by delta x. Okay, and that's what slope is. Okay, so what is it used for? I have already said that to you. Linear regression is basically used for prediction, and also used to know relationship between y and x. Of course, in correlation also you can know the relationship, but then you cannot know if x increases by 1 unit, what is going to be the increase in y. You also get to know whether there is a negative relationship, positive relationship, just by looking at the coefficients, the value of m, which is the slope coefficient. If it's negative, then there is a negative relationship. It is positive, there is a positive relationship. Okay. Okay, so we'll take an example to understand later on.